Okay, so today we will have a look at some of more advanced problems. By advanced problems, I mean that the questions will be more in terms of the sentences or language that we use in our daily life. So in your daily life, you don't get a question in terms of an equation or directly in terms of numbers. You have some information, some data, and you have someone describing the situation in some words, and our task then is to understand the question, understand the situation, represent the unknowns with the variables, and then bring in the different mathematical equations and everything that we have learned, and then try to find the answer to the real life questions. So when I say advanced example, I just mean that the questions will be more in terms of the general words that we use, and we need to interpret the question. Okay, so let us start with the first one. It says find the 11th term from the last term towards the first term of the AP. So we have been given an AP 10, 7, 4, so on up to minus 62. So we need to find 11th term from the last term. So we need to start counting from the last or towards the end side, and we need to get 11th term from this side. Okay, so if one approach would be first to find how many numbers are there in this AP. So we know the first term, we know the common difference, we know the last term. So we should be able to figure out how many terms are there. And once when we find how many terms are there, the last n, then we can easily find, then we just need to interpret which term would be 11th term from the end. And once we have that n value, then we can easily find the value for that term. Okay, so let's get started. So we have A as 10, D as 7 minus 10 is equal to minus 3. And we have our last term as minus 62. So we again bring in our general formula, Tn is equal to A plus n minus 1 times D. So what do we get? If we put minus 62 here, we need to find the number of terms. How many number of terms are there? So minus 62, and we get 10 plus n minus 1 times minus 3. Or we could write this as minus 62, 10 minus 3n plus 3. So this will be minus 62 and then minus 13. So minus 62 minus 13 minus 75 is equal to minus 3n, or n is equal to 25. Okay, so what do we have now? So we found that there are 25 terms in this arithmetic progression. So we need to find the 11th term from the last term. So we need to interpret this a bit. Let's say we have 25 terms. Okay, so this is 25th, this is 24, this is 23, 22, and we are coming here. So I'm just writing the numbers, terms. So first term, second term, third term, so on up to 22nd term, 23rd, 24th, 25th. So now let's say if we were given to find the fourth term from the last. So which is the fourth term from the last? First, second, third, fourth is 22. So the way we find it is 25, that is the number of terms, minus 4, this is equal to 21, and then we add one more to it. And then, so this is the fourth term. So the thing here is that when we are subtracting 4 terms from 25, we are actually taking out the fourth term. So we need to add one more to get the fourth term. So in this case, we need to find the 11th term. So what would that term be from the start? That would be 25 minus 11, 14, and we need to add plus one more. So 15th. So 15th term from the beginning would be 11th term from the end in this case. Give it a bit of thinking and you will get to it. So now the question just boils down to we need to find the 15th term in this AP. So what would be the 15th term in this AP? It would be equal to A plus n minus 1, that is 14, times common difference minus 3, or this would be minus 42 plus 10 minus 32. This thing here is just an extra thing we did to understand which term would be 11th term from the end. I think it's better to do a quick review of what we did. So we had our first term, we had our last term, we had common difference, so we could easily find the number of terms. Once we have the number of terms, we just need to find which is the 11th term from the end. So since there are 25 terms, then the 11th term from the end would be 25 minus 11, 14 plus 1, 15th term. And why would this case be here? So when we are subtracting 11 from the end, so we are taking out the 11th term. So in order to get back to 11th term, we add one more. There is one more alternative way to find the solution much more easily. So what do we have here? We have our AP as 10, 7, 4, minus 62. We need to find 11th term from the end. So one thing we could easily do is just flip it. Flip our AP. If an AP is flipped, it will still remain AP, right? If we have, let's say, just these three terms, 10, 7, 4 as our AP. Now if we just write in terms of flip it, then what happens? It is still an AP, but here the common difference was 7 minus 10 minus 3. In this case, the common difference becomes 7 minus 4 is 3. So what we do here is just flip it. So if we flip it, what do we get? Minus 62, and here it was supposed to be minus 59, and so on, and then you get 4, 7, 10. Okay, so it's the same AP but just reversed. So what do we have here? A as minus 62, D as 7 minus 4, 3. So the common difference sign changes since we have flipped it. And now we just need to find 11th term from the last term. So 11th term from the last term would be 11th term from the beginning. So we can now easily write T11 is equal to A plus 10 times D, or we have A as minus 62 plus 10 times 3. This is equal to minus 62 plus 30 is minus 32. We reached at the same answer but in a more quicker way. What we did was we just flipped the AP. So instead of counting the terms from the last, we are again counting terms from the beginning, but we just need to keep in mind that the sign of common difference changes. Instead of decreasing, now the AP is increasing. Let us have a look at another example. Okay, so we get to money. So if you start earning money sometimes, then you will probably invest it somewhere, and when you invest, you get certain amount of interest. So we have here as simple interest. So by simple interest, it just means a simple interest, and by that we mean that the interest amount is calculated just on the principal amount. So if you deposit rupees 1000 and the rate is 8% per year, so at the end of 1 year you will get the interest as 8% of rupees 1000, which is equal to rupees 80. 8 by 100 into 1000. So at the end of first year you will get rupees 80 as interest. So you'll have your principal amount 1000 plus rupees 80. Now the thing with simple interest is that even now in second year, the interest will still be calculated only on the principal amount. So in the second year as well, you will get the interest as rupees 80, but in the second year the accumulated interest will be rupees 80 for first year and rupees 80 for second year, that is 160. And similarly for third year it will get 80 plus 80 plus 80, that is 240. Okay, so let us get to the question now. It says a sum of this rupees 1000 is invested at 8% simple interest per year. Calculate the interest at the end of each year, and we need to find, do these interest form an AP? Okay, so first let us address the first part of the question. So the simple interest at the end of first year would be, this would simply be 8% of your principal amount. So 8 by 100 times 1000, and since it is just 1 year, it will multiply by 1, so it is equal to rupees 80. Similarly, simple interest after your second year, what will it be? 8 by 100 times 1000, and now it's your second year, so you will have accumulated it 2 times, then it is equal to 2, so you have 160. Similarly, simple interest for your third year, it will be 8 by 100 times 1000, you have accumulated 3 times, so it will be 240. One simple formula, if you want to write this thing in terms of formula, it is simple interest is equal to whatever is your principal amount, P, you multiply it with the rate and the time you have invested divided by 100. This is your formula for simple interest, what we wrote here. Now we need to check if these interests are forming an AP. In this way you can find for fourth year, fifth year and so on. So we have 80, 160, 240 and so on. So if the sequence is in AP or not, how do we check it? We start calculating the common difference. So 160 minus 80 is 80, 240 minus 160 is 80, 80. So yes, they do form an arithmetic progression. Now the question says if they are forming an arithmetic progression, we need to find what is the interest after 30 years, which simply means that we need to find the 30th term. So it will be equal to first term 80 plus 30 minus 1, n minus 1, 29 times d. The common difference is also 80. So here if you take 80 as common, 80 times 1 plus 29, 30. 80 times 30 would be 2400 rupees. So this will be the accumulated interest at the end of 30 years. You can also check it here. So accumulated interest after 30 years would be 8 by 100 times 1000 times 3, which will be equal to rupees 2400. So this will be your interest. So at the end of 30 years you will have 1000 rupees at your principal investment, and then the interest that you would have accumulated is 2400 rupees. So in the end you would have 3400 rupees. Let us have a look at one more example. So here we have, in a flower bed, there are 23 rose plants in the first row. Okay, so we have a flower bed full of roses. In our first row we have 23 roses. It would have been nice if I could draw roses, but you can try to draw roses. Yeah. So in the first row we have 23, in the second row we have 21, in third we have 19, and so on, and in the last one we have 5 rows. So we need to find how many number of rows are there. So what do we have? We have a sequence 23, 21, 19 and so on up to 5. So one thing you could do is you could just simply keep on writing 19, 17, 15 and so on, and you can count how many number of terms reaches to 5, or we could use our knowledge of arithmetic progression. So we have A as 23, D is 21 minus 23 minus 2, and our last term is 5. So now we just need to find what is the n, what is the number of terms in this arithmetic progression. So we have last term 5 is equal to a plus, let's say it is nth term, so n minus 1 times minus 2. Therefore we will have 5 minus 23 is minus 18, and this will be divided by minus 2 is equal to n minus 1. So we have 2, and therefore we have n as 9 plus 1 is equal to 10. Therefore we have 10 rows in this flower bed. You can find all the lectures on arithmetic progression in this playlist here, and also the lectures on pair of linear equations in two variables in this playlist here. Also, please subscribe to the channel and share it among your friends. Thank you.